Hello, welcome to this quick RRT star introduction video. So, as we know, there are many different variants of explaining RRT and RRT star out there. So this video is not intended as a full coverage of all the variations out there. It's just a very simple, intuitive explanation, uh, one possible way of seeing things through a clear picture. So let's get started. The RRT star is an improvement of RRT algorithm, and here's how it works. The problem is that you have a starting point and a goal point, and then there might be some obstacles in your way, and then you want to generate the shortest path possible from the start to the goal. So let's say we already generated a set of tree branches uh, like this in these blue dots, and then we're just going to look at one step in this problem to see how RRT star generates new point and updates the tree according to this new point. Let's say that we sampled a new point, this yellow point, by by randomly selecting a location, and then um, it has to be within the step size of existing points. So it is, as you can see, that it's still smaller than the step size from some of its neighboring points. So what do we do next? The the newly generated point, if we don't have RRT star and we just use RRT, it is plainly going to select the closest point, which is uh, this one here. It is just going to connect it and that's it. But since this is RRT star, that's not what we do. What we do is that now we're going to actually look at a broader sets of neighborhood points instead of just looking at the closest neighbor. So this is what we do. We introduce a concept called the neighborhood or neighborhood radius. And then we're going to see who are in this neighborhood region. So let's do that. Now we have these nice circles to represent step size and neighborhood. We are just going to drop it on top of our newly created point. And we can see that we can place it right there. And then we have 1, 2, 3, 4, 5, 6 different points that's in the neighborhood, in that neighborhood range. And now what we're going to do is that we're going to test all those points within the neighborhood and see which from which of those points can we achieve a shortest distance from the start to the newly created point. So let's just do that. Let's just draw 1, 2, 3, 4, 5, 6. We're going to draw all these 6 lengths. And then we're going to calculate which of those paths from the start to the goal point uh, that produces the shortest length. And, by a simple observation, it is not too hard to realize that it's this one here. So this is the one selected, one of the 6. Okay, so are we done yet? No, we're not done yet. In an RRT, after you find the new connection, you're just gonna say, okay, I am going to add this point to the existing pool of points to the existing tree, and we're done. But no, in RRT star, there's an additional step where you actually not just create this new connection, but you're going to also update your neighboring points, helping them. So what do we mean by that? Now we're going to say, okay, now we take this new point. Is this new point uh, going to help reduce the the total the total length or the cost from the start point to any of our neighbors? Can we help our neighbors reduce their cost? So that's what we're going to do. Now we're going to look at again all these 6 different neighbors. And let's see if we can actually their reduce their distance, yeah, their cost or their length. So we're going to draw these arrows again, and we're going to see and compare uh, if these new errors could provide a cheaper alternative. And let's see. So for this point, we have two choices. The original choice is probably still good, better. The second one, we can see that the new path actually provides a better choice. So we're going to delete this original path, right? Let's just do it again. You see that we have two choices here to this node, to this neighbor node, and the new path that involves the new point, it actually reduces the the cost to this neighbor point. So we're going to remove the original point and use the new path. And what about this one? Yeah, as we can see, the previous length was pretty lengthy, and it is not the best choice. And with this new path here, it definitely is going to be better. So we're going to remove the original one, use the new one. Um, as for this one here, it's a little bit trickier because they're about the same. Let's say the original one is better. Um, and then this one, of course, the original one is better. So, okay, so that is the final step in RRT star. We just updated or optimized um, the, the, the tree, the paths for our neighbors, in addition to finding the best path for the new point itself by looking at its neighbors. So in a way, it's like mutually beneficial by adding a new point into a neighborhood. The new point gets some optimal path from its neighbors, and it also updates so that it might improve the cost for some of its neighbors. And this process goes on and on, and when you keep updating this RRT star tree, you're going to see that it optimizes in a smarter and faster way than the original RRT algorithm. So hopefully this is helpful for your learning and understanding of RRT star. If you have any comments or questions, please ask them below, and see you next time.